like to be able to present this lecture to you in the most fundamental way possible, so that you will be able to pass some knowledge in this session. I don't know, should I just go ahead? I'll go ahead and then begin the discussion, or you want to have some
No, you
introductions from the time before?
No, you can go.
Okay, all right. Networking, types of networking, wireless networking, WAN technologies, W1 technologies, and then network topology. We'll do some Q&A sessions afterwards. Feel free to interrupt me and ask questions at any point in time.
Hello, Mumin, can you come closer to your mic? Some students are complaining that they are not hearing you. Yes, it's clear now.
Can you hear me now? Okay.
Yes, it's okay now, yeah.
Okay. All right then. So like I was saying, you can ask questions as I'm going on, but there's a special Q&A session at the end of this module. So do feel free to interrupt me at any time when you don't understand anything. All right. So we're going to start with networking. First question that we're going to look at: what is a network? A network refers to two or more connected computers that share resources such as data, a printer, an internet connection, application, or a combination of these resources. What this basically means is that the two devices that are able to communicate with each other basically forms a network. Depending on what they share or how they actually communicate with each other defines the different types of networks that we have. It doesn't really matter where the device is located. It can be anywhere and still be able to communicate with any device elsewhere in this world as well. So you and I actually having this training session from my computer to your computer is over a network. You have your internet connection. I have my internet connection. I bet some of us are on MTN and some people are on other providers, but we are still able to communicate with each other. That is the beauty of networking. There are various types of networks, and we'll be going into some of them to give you an understanding of how the various communications that are happening around us are actually happening, and the technologies that they use to start with. We have the PAN network, which is interconnection of IT devices within the range of individual persons. So this has to come in when you create a Bluetooth connection with somebody just close to you to share a file, or to even share internet with Bluetooth connection. That is what PAN actually means. We have network in a small geographical area. It could be in a room, a building, campus, which is called the LAN. So in your house, if you have Wi-Fi that's actually in your house, and you have a small router and you have cables connected to it via a PC, that small area that you have in your house can be termed as a LAN. So it's a local area network. It doesn't go across. So those computers in your house, when they communicate with each other, They are on a local network. Then we move on to the network in the city, which we call metropolitan area network. So if we are both in Accra and we are communicating with each other, we are doing what we call metropolitan area network. Then we have the wide area network, which spans across regions, countries, everywhere. Basically, the basics of the wide web, which is the internet. We have wireless technologies that basically means that there are no cables that are being used in communicating from one device to the other. Computer networks not connected by cables. They use radios to connect, which is also broken down to different types. That is the WPAN, WLAN, WMAN, and W1. It's basically the same things that we have, but whereby cables are not involved in any way. One technology we have over the years, we've evolved from various technologies that have seen tremendous improvement in the networking industry. We started with these lines, frame relays, and now we even have broadband access, and we have MPLS VPN going across various service providers. Now, these wide area networks are mostly used for communication between companies, or even the same company. Within the same company, you can have branches across different areas, and you're able to use your wide area technologies to be able to connect these branches to each other. Now, W1 technologies are wireless WAN technologies, which we've seen various. Most of us use these things without even knowing that this is what we're actually doing. It's a term now that when somebody goes like, my internet is slow, the first thing you hear is, are you on 4G? If you're not on 4G, then don't even talk. Or are you on LTE or Wi-Fi? We use these things and we don't even realize what kind of technology it is. You ask somebody, okay, what does it mean to be on Wi-Fi? The person doesn't really know, just knows that, okay, there's Wi-Fi. I'm connected to a Wi-Fi, but what it does, the person doesn't actually even know what it means. So in this, by the time we are done with these lectures and these classes that you're having, you should have a basic understanding of what it is to be using these terms, and you should be able to use them appropriately. Well, we've seen the various types of networks that we have. Now, we want to look at the topologies of network. That is the way networks are designed and what kind of benefits they give us when they are designed in these ways. In a traditional network where I set up my network in my home, I mostly will just have a single device with all my PCs connected to that so that we can share information. If I'm looking at connecting different locations to a head office network, I'll probably be looking at what we call the star topology. When you see on the picture on your right side, you see the star topology over there, which is mostly used when people are connecting branches to head office, because your branches actually pick information from your head office and also send the information to the head office. So normally branches don't actually communicate with each other. They just communicate with the head office. So it makes sense to have just a connection from that branch to the head office, but not actually connecting branches to each other. Then we have what is called ring topology. Ring topology is used to give an added value of when you have communication that has to go to across multiple areas. You need connection from one location to the other, but all the locations are supposed to be able to communicate with each other. You can use what we call the ring topology. What advantage this has over the star topology basically is that when there's an issue at one branch, the other branches can still be able to communicate with each other. We have the extended star topology. The extended star topology basically means a cluster. You first group your branches that need to talk to each other before talking to the head office. So you group them into smaller clusters before connecting, like a hub point of that connection to the head office. Then we have the mesh topology. Now the mesh topology is usually the most preferred topology in terms of resilience and high availability, and it's usually used by service providers because it provides alternate routes to every single location or site, and you are able to reroute traffic as and when you want. So basically, it's difficult to have an outage when you are running a mesh topology, because each branch is actually connected to every other branch. So it's a direct connection to every other branch. If I lose my connection to branch B, I can probably go to branch C to get to branch B. So you are always connected. So breaking it down, the bus topology, commonly referred to as a linear bus, all the devices on a bus topology are connected by a single cable. So anytime the cable has an issue, everybody is cut off. One single cable, and we all just connect to it and take our connection from that. This is mostly what you see even in the electrical wiring in a building. Most people go with this linear cabling because of where we are coming from in terms of technology. We started, electricity was there before networking started. So it makes sense to mimic what was being used from the electrical point of view. Before the star and the other topologies were introduced. The star topology is the most commonly used architecture in Ether land. When installed, the star topology resembles spokes in a bicycle wheel. Larger networks use the extended star topology, also called the tree topology. When used with network devices that filter frames or packets like bridges, switches, or routers, this topology significantly reduces the traffic on the wires by sending packets only to the wires of the destination host. Ring topology. A frame travels around the ring, stopping at each node. If a node wants to transmit data, it adds the data on as well as the destination address to the frame. So what it means is that it's like a bus. A bus goes round. So when it's going round, it just keeps picking up the data, and whilst it's going round. If you don't have anything to send, you don't respond, or you don't actually do anything. It just will move on to the next bus stop. And the frame then continues around the ring until it finds the destination node. As in when you send a message, it picks up the message. It will continue around every hop along the line. So at every bus stop, it will stop. If it's not your stop, you don't get down. Until you get to your stop, then you stop. Then you get down from it. Like I said, the mesh topology is mostly the best of technology being used currently. Mesh technology connects all devices, that is, to each other for redundancy and fault tolerance. This is, as I said, once every single node that needs to talk to another one will have a direct connection to it. It is used in one to interconnect LANs and for mission critical networks like those used by banks and financial institutions. Implementing the mesh network, implementing the mesh network, mesh topology is expensive and difficult. As said, every single branch needs another link to every other branch that a company has. Imagine a company like GCB. You know the number of branches they have across the country. If every single branch has to connect to every other branch that they have, you can imagine the cost that it will be. Now, we have some quiz. I don't know if you want to ask me questions first, or you want me to go ahead and ask my question. Do you have any questions for me? Okay. Yeah.
From my side, no questions.
Okay. So my first question: can a smart TV be part of a WPAN network? What are the devices which can be connected to it? And on what media? You remember what I explained what the PAN network is?
Yes.
A PAN network is basically the personalized area network.
Yeah. So a smart TV can be part of a PAN network because you can connect your phone Bluetooth to your TV and stream some images to it.
Thank you. Thank you very much. Any other example? Any other example?
I think modem via Wi-Fi.
Wi-Fi. Thank you. That is correct. All right. So you've actually mentioned the media. We have used the Bluetooth and we also use the Wi-Fi as well. So what are the major differences between a leased line and a broadband access network? First of all, let me ask this. Tell me what line is actually.
Hello, Mumin. They are not hearing you.
Okay, I'm asking, first of all, who can tell me what a leased line is?
I think it's a type of a wireless one, a W1.
Okay, you're close, but
okay,
not exactly. Any other?
It's one technology with dedicated connection between the customer and the service provider.
Okay, that is still close, but you can add more. Is it always between a service provider and a customer?
Or dedication between two endpoints.
Very good. So a lead line is basically a wide area connection between two endpoints. Okay, and then the broadband access. I'm sure most of you are using broadband today. Can anybody explain what the broadband access is? Hello? Hello?
Yes, we are here.
Okay. Any idea on broadband? See, there's no wrong answers here. So I would urge everybody to.
Hi, my name is Robert Steve Welcome.
Hi, Robert. Hello, was Robert saying something?
No. It was a random video that was playing.
Oh, okay. All right. So broadband is basically a connection over. Hello, can you hear me? Am I breaking? So like you guys.
No. It's okay. We can hear you.
Okay, all right. So broadband currently is being used as our internet access that we're using. It's a technology that has been around for a very long time. Basically running over coaxial cable before moving into fiber optics, and now we are using it over wireless technology. Now, broadband itself can be used for wide area network or even internet access. But what broadband does is a database transmission technology which monitors your data consumption rather than your speed or the bandwidth that has been guaranteed for a particular link that has been provided. So these lines mostly deal with bandwidth, and then broadband deals with data consumption. I hope that is clear.
Yes, please.
Okay. My next question is, can we consider 3G wireless?